The Hardy-Weinberg principle, also known as the Hardy-Weinberg equilibrium model, states that allele frequencies and genotype frequencies in a population will remain constant through generations if 5 conditions are met.
The 5 rules that a population must follow in order for it to be in Hardy-Weinberg equilibrium are large population size, random mating, no gene flow, no mutations, and natural selection cannot be acting on the population. If these limitations are met, then the population can be in Hardy-Weinberg equilibrium.
There are a few equations and symbols you will need to know in order to complete a Hardy-Weinberg problem. The equations p squared plus q squared plus 2pq equals 1 and p plus q equals 1 can be used to determine the dominant and recessive allele frequencies in a population and the genotype frequencies in a population.
P represents the frequency of the dominant allele, while Q represents the frequency of the recessive allele. P squared represents the frequency of the homozygous dominant genotype. Q squared represents the frequency of the homozygous recessive genotype, and 2pq represents the frequency of the heterozygous genotype.
Depending on the problem, you will have to use the 2 equations and variables to determine one or several of these factors. We will go through a problem that shows a few ways in which we can use these equations to figure out the allele and genotype frequencies in a population.
In this problem, we are given members of a population of corn and are asked to determine the frequencies of the alleles in the population. The first part of the problem states, in corn, kernel color is governed by a dominant allele for white color and by a recessive allele. A random sample of 100 kernels from a population that is in Hardy-Weinberg equilibrium reveals that 9 kernels are yellow and 91 kernels are white. Calculate the frequencies of the yellow and white alleles in this population.
A basic rule of thumb when doing a Hardy-Weinberg problem is to start with the homozygous genotype or allele frequency, because that is the only one you can know for certain. Because this problem gives us members of the population, we can easily find Q squared. In this problem, 9 out of 100 kernels exhibit the recessive phenotype, which is yellow, so we can calculate Q squared by doing 9 divided by 100 and find that it is 0.09. With this number, we can then calculate the dominant and recessive allele frequencies.
We can find the frequency of the recessive allele, which in this case is yellow, by square rooting the Q square value. When we do this, we find that Q, or the yellow allele frequency, is 0.30. Then, to find the frequency of the white allele, we use the equation P plus Q equals 1. When we plug in the 0.30 for Q, we find that P, or the white allele frequency, is 0.70.
The second part of the problem asks us to calculate the percentage of the population that is heterozygous. To do this, we need to use the equation that states that the heterozygous frequency in the population is equal to 2pq.
Because we found P and Q previously, all we have to do is plug in those numbers to the equation. Plugging the numbers into the equation, we get 2 times 0.30 times 0.70, and calculating that, we find that this equals 0.42. We multiply this number by 100 to find that 42% of the population is heterozygous.
Well, we hoped we helped you understand the Hardy-Weinberg equilibrium model and showed you a few ways in which you can use the equations to solve a problem.
Good luck, and we hope that was helpful.